Welcome to DozoChem. This video covers the ideal gas law, PV equals nRT. The ideal gas law is an equation that relates different properties of gases. The P in the equation stands for pressure, and it has to be in the units atmospheres when you plug it in. Sometimes it'll be given in the unit millimeters of mercury, mmHg, so you'll need this conversion here. 1 atm is 760 millimeters of mercury, so you can get it to atmospheres before you plug it in. The volume needs to be in liters, so if it's in milliliters, you're going to want to convert. N stands for moles, so if it's in grams, you would use the molar mass to get to moles. Temperature needs to be the Kelvin temperature. To get that, you're going to take degrees C and you're going to add 273 to it to get the temperature in Kelvin. And the last thing in the equation is R, that's called the gas constant, and here's its value with units. So what we'll do now is do 4 different examples where we solve for the 4 different variables in the equation. So let's start with pressure. What is the pressure in millimeters of mercury of 0.0675 grams CH4 gas in a 325 milliliter flask at 22 degrees C? So first thing we're going to do is solve the ideal gas law for P. So if we do that, we get P equals nRT over V, and then we want to just come down here and start plugging in each of those variables. So N is moles, and they gave us grams, so the first thing we're going to do is convert grams to moles. So that's all set for N. R is a constant, so we don't need to do anything for that. T is Kelvin temperature, and they gave us Celsius, so we're going to add 273 to it to get it to Kelvin. And on the bottom, they gave us milliliters, and we're supposed to use liters in the equation, so we would divide by 1,000 and get that to liters. So at this point, everything's in the correct units. So if I go and I do the math, you'll see that moles cancel here, liters cancel, and the kelvins cancel. And that leaves you your final answer in ATMs. So 0.313 ATMs would be your final answer. But they did ask for it to be changed to millimeters of mercury. So the last thing you're going to do is convert using 760 millimeters of mercury per 1 atmosphere to get your final answer in millimeters of mercury. Next example, we're going to be solving for volume. So they give you the grams of O2, they give you the pressure, and they give you the temperature. So volume, V, equals nRT over P. So we do the exact same thing we did on the last slide, which is change the grams of O2 to moles. And notice again, it's O2. So the molar mass is double what the periodic table says for oxygen, 2 times 16.00. R is a constant. Temperature needs to be changed to kelvins by adding 273, and the pressure was given in millimeters of mercury. It's supposed to be in atmospheres, ATMs, so this time we're going to divide by 760 or multiply by 1 ATM over 760 millimeters of mercury to get rid of millimeters of mercury and convert it to atmospheres. So now when I do the math, this time the moles are going to cancel, K is going to cancel, ATMs is going to cancel. Whoops. And you will get your final answer in liters from the ideal gas law, but then they asked it to be changed to milliliters, so you would just multiply by 1,000 to get your final answer in milliliters. Next example, it's going to be one where we solve for moles. So this time they're giving you a pressure in millimeters of mercury, they're giving you a volume in milliliters, and a temperature in Celsius. And they want to know how many molecules. So we will have one final step at the very end. But for now, we're going to solve for N, which is PV over RT. So change the pressure from millimeters of mercury to ATMs, change the volume to liters, and change the temperature to kelvins. At that point, liters cancel, ATMs cancel, and K cancels. So your answer using the ideal gas law at that point gets you to moles, but they ask for molecules, so the last thing you would do is multiply by Avogadro's number to get the number of molecules. Last example is solving for temperature. In this case, they give us the grams of N2, the pressure in millimeters of mercury, and the volume in milliliters. So if we change the ideal gas law around, T is equal to PV over NR. So for P, we're going to change it to ATMs. For V, we're going to change it to liters. And down below for N, we're going to change the grams to moles. And again, same as the previous slide, it's N2, so the molar mass is 28.02, not 14.01. Then if I do the math, ATMs cancel, liters cancel, and moles cancel. So that's going to give me an answer in Kelvin, but if you go back to the question, they asked for degrees Celsius, so we're going to subtract 273 to get our final answer in degrees C. So that's it for this video. Good luck.